All right, okay. Welcome everyone. I am Anish, and I'll be talking about scaling GenAI inference today. If you scan that barcode at the bottom of the screen there, it should take you to a slide share presentation, and so you can follow along. You don't have to take pictures and stuff unless you want to. You can take pictures if you like, but it's all on there. You can follow along. So I'll be talking today about taking a few projects from prototype to production. So a bit of background. I work at Script. Script contains three brands, Everand, SlideShare, and Script. On Everand, we have premium content from various publishers like Penguin Random House. It contains lots of ebooks and audiobooks, everything from like mystery, romance, sci-fi, fiction, non-fiction. Script is another brand where users upload content. They upload a lot of interesting content. You should check it out. We have stuff all the way from like lecture notes, research articles, to things like software installation guides, manuals, all that sort of stuff. And SlideShare, well, SlideShare hopefully is the place where you're looking at this presentation. So the most important bit about this slide I want to cover is we have a fairly large corpus. We have about 280 million pieces of content. We have a lot of audiobooks, both in terms of the number of audio that's consumed by people and hosted, millions and millions of hours. We also are multilingual, so we have over 20 languages. All right, so how did this get started? The way this got started is on a project called metadata extraction. So in this project, it was one of the first ones we did using GenAI and LLMs. The idea was that we want to extract text from ebooks, and we want to transcribe audiobooks, extract the text, and then we want to send it over to an LLM with a prompt to extract metadata. The kind of metadata I'm talking about is stuff like characters, character plots, themes, tropes, that sort of stuff. Because we're going to use that to help users find content on our site, to discovery and recommendations, and we were going to help search and SEO. So the bigger picture, you can think of this as we have some data that we need to prep for inference. We want to combine that with a prompt, and then finally we want to derive some value. Now the unique challenges that we have, like I was saying, we have lots of languages. We know that LLMs are really good at handling English, but not so much so in all the other languages. We have languages such as Spanish, Portuguese, Indonesian. We also have a fair bit of audiobooks and ebooks that we need to go through. And at the time, we needed to use real-time Whisper because Databricks had not supported batch Whisper at the time. So before actually starting on this process, we need to evaluate LLMs. The graph, by the way, I'm trying to show that we started off really slow with audio transcription. And then over time, week 5 and week 6 was when we really figured out how to scale stuff and get lots of audio transcription going. So this slide talks about how the journey started and where we were able to get to. Speaking about evaluating LLMs, this is from a more recent project that I wanted to show you all. Evaluations are still under progress for this project, and we don't want to disclose what models we're talking about here. But this is a true graph. As you can see, cost and quality are really important because Model 3 is really cheap compared to Model 1. And Model 3 performs at the same level as Model 1. So this sort of stuff is really important because when you're talking about a corpus of our size, it equates to millions and millions of dollars of savings. Talking about prompt engineering for this specific project, there's a few interesting things that I want to discuss here. Unit testing. So the previous graph you were seeing that was talking about quality was unit tests. Unit tests is a way for us to ascertain if the output can be used by downstreams. It's also actually a good way to figure out if you have hallucinations. We worked with our data science team to kind of look at the output data and figure out a few metrics, such as if the output is not parsable, if all the key value pairs aren't represented, and if it's not the correct data type, then we failed the unit test. For the particular project, we annotated about 20 ebooks and audiobooks. And after the annotations were done, the scoring was similarity measured. So what that means is we have a particular character or character plot that the annotators have suggested. If it's similar to the LLM output, then it scores really well. Otherwise, no. We did a similar thing for precision and recall. So now we were ready to start our inference. I'm actually going to switch to using this one. I don't know why that's not working that well. What I did was I went ahead and on a Databricks notebook, I tried to do audio transcription. This code shows what I did. Essentially, I need to convert the input data, which is MP4 files, into base 64 bytes. So I did that. And then after that, I sent it over to a real-time whisper endpoint. You can see the transcription, it's at the very bottom there. It looks kind of okay. So that was fine, but it was really, really, really expensive and very slow. So why was that the case? The reason for it being really slow and really expensive was because I was spending a lot of time just waiting and waiting. The servers, the CPUs, were doing one particular piece of audio file at a time, and they were making single sync requests to the GPU, and this ended up becoming really, really, really expensive. It would have taken a really long time and cost a lot of money. So this is, a bit of a naive solution, but a start. So then we asked Databricks for help. We were like, please help us. This isn't working. It's going to take a really long time. You can ask me afterwards. I did a whole bunch of other stupid mistakes too, which ended up costing us a lot of money as well. I left it running. I left those notebooks running for a night, and it was really expensive. So, anyways, the Databricks team really partnered with us. They kind of talked to us, understood our problem, kind of tried to figure out what they should suggest, and they told us to go with Databricks workflows and batch inference. At the time, they said async inference, but now we have batch inference at Databricks, so I'm pretty sure that's what they would recommend. How many of you all are familiar with workflows? Okay, about 25%. So workflows are really easy to get started off with, in my opinion. If you scan that QR code, it will take you to the intro page about workflows. So in my opinion, start off with the UI, set up a task. You can point a task to a notebook, and then you should parameterize your notebook. In our case, the parameters would be document ID or batch ID. Batch ID is just a collection of documents in an input table. And set your concurrency. Concurrency is basically the number of tasks or notebook instances that the workflow will run at the same time. The next thing I wanted to take a look at was if there are APIs. And I'm very glad, I'm very happy that APIs exist for everything. That piece of code that I'm sharing there is the same piece of code I've been using for the last, I think, 1.5 years. It's very simple. Given a particular job ID from your workflow and given params, you can trigger any of these workflows. And based on your concurrency setting, it'll run those many tasks. Now, for visibility, one of the things, and learning from my previous mistake about spending a lot of money not knowing, it's very important to try to finish, in my opinion, a task within 1 to 2 hours, and to also kind of insert rows or do some sort of insert every 100 or every 1,000 rows at a time into the output table. That way you know stuff is happening and things are working. And then the other thing we discover is that there's a constraint. The constraint is that if you have a particular task that's been in queue but hasn't started for 48 hours, it will automatically get canceled. So now knowing these things, I next was thinking about how to structure the notebook. A few important things here are that we work with our data scientists, and we think it is really important, and it's been working out really well for us to log experiments like all your evaluations and results, and store the prompts and the versions so that everything is accessible to you within the notebook in your workspace, and you can put it on GitHub. For the 48-hour limit issue, what I did was the params can be anything. They don't have to be integers. They don't have to be doc IDs. They don't have to be single batch ID. I can supply an array of batch IDs. So in this case, if batch ID 10 doesn't start within 48 hours, no problem, because the notebook is running, right? It's been running from the start, and the code there shows that essentially you're sequentially processing batches and you're producing outputs every 100 or 1,000 rows at a time. Now, in terms of thinking through this whole problem and thinking about solutions, this is a very important point, I believe. There's no big problems, there's a lot of really small problems. If you make a problem into small little problems, they're much more easier to solve. If you scan that QR code, it'll take you to Everand. There's a really good book about bulletproof problem solving that I highly recommend. Also, especially just for you guys today, we have a promo code, DAIS25. It's DAIS25. You can use that promo code and you'll get a free unlock. So with that, I worked with the team. We came together to think about a new way of solving this problem. And this way of solving the problem has lots of benefits. It's not only about splitting the problem into smaller chunks for the purpose of pipelining. It also helps you understand where the risky portions are. It also helps you understand where to put more resources on, what things you already know how to do, and what are the net new things. So we thought about it in this way. And thinking about it in this way has an advantage that preparing input data is something that we are already familiar with. So I'm going to talk about a few details to this. The thing that we think is most important about preparing input data is that we should partition the data to whatever batch ID and number of books can finish in an hour or 2 hours by an LLM. I'm showing an example there of the audiobook transcription. And so by testing, we came up with about 1,000 books per batch finishes in that much time. Now I'm doing it all using Spark. So I think using dedicated compute is a really good idea for this. I wouldn't use serverless compute for this because dedicated compute, you can select your M or C type cluster. We're on Amazon, so that's why M or C type clusters. You can do the same thing on other clouds. You can check the metrics and really optimize that. The reason for using workflow for this thing was that I could parallelize batches. So I could do 100 batches at the same time in the workflow. And if a batch finishes, the batch fails. If it finishes, that's awesome. If it fails, I just have to rerun that particular batch. So I can figure out my anti-join and just do that one. So now we get to the place about talking about inference. And this is where I think serverless compute shines. So the main thing about this image I'm trying to show is use serverless compute. You don't have to set up any of your configs and specs for dedicated compute. Serverless compute is going to be really good at doing this because the bottleneck is really the inference. It's not going to be your serverless compute. So you can save time by just doing it that way. So for real-time inference, the code we came up with, and this is the same code we've been using for multiple projects, is we look through all the batches, we do a collect operation, and that collect operation brings in the data onto the driver, right? So it's basically selecting like 1,000 books. And then this is showing you a real-time call that's happening. The real-time call is essentially going to one of our LLM APIs, and I'm saving results 1,000 at a time in this case. Now, that talks about real-time inference. We've been using the same thing for batch inference. The code shown below is for AI query, which I highly recommend because it's with the serverless batch inference that's available, it's very easy to use with different LLMs, especially Llama. But you can also use the same thing for using OpenAI or Gemini, Vertex AI, because all the differences between batch inference and real-time at this level is instead of making single API calls or async calls, you're creating a batch of JSON payload with 1,000 documents in our case, and then you're polling the batch and getting the responses and saving those responses into the output table. So speaking about results, we have been able to process across multiple projects quite a few different pieces of data. This spans not just GenAI projects. Some of them are, as you can see, document embeddings and transcriptions, but also other projects where we have external APIs involved. And we've been doing, most recently, multimodal. So that's why we have been doing screenshotting images and extracting images. So in terms of the core improvements, these are the ones that I think are really important. Before developing the system and this process, we used to take about a month using Airflow and Databricks jobs to complete this process. Now preparing data, running your API calls to the LLM endpoint, and then finally validating and producing the output data, we're able to do it in 2 weeks. The cost estimation is also a lot faster because we're able to kind of, just work on a POC for the first 2 stages and then extrapolate the numbers. So I would just do 1,000 books, make sure the job finishes in an hour or 2, and make sure the outputs look okay, and then I can extrapolate those numbers. And so the project that was going to cost $1 million ended up costing about $300,000 with all this optimization. So the thing I want to recap is we have a system now that, these were requirements before. You can think of them as goals. We were able to achieve this. We were able to separate our distinct steps for preparing input data using Spark that's fast, that's independent, for performing API calls using serverless. We were able to figure out how to control concurrency using serverless, just making it sure that it's at the API limit, and made it easy to change prompts. And finally, the validation is a separate step at the very end. So we are not validating while performing API calls. We're just saving the JSON output as is, and we're parsing and validating afterwards to make sure that it's going to be usable for downstreams. Yeah, so this slide, this captures essentially what we did. And lastly, all the results are available in the Unity catalog for all downstream consumers. Check out tech.script.com. We are hiring. There are lots of other cool projects that we work on, other than the one I spoke about today. Lots of cool stuff there. We have blog articles coming out constantly. I do not have all the time. I only have a minute left, so I do not have all the time to discuss everything in detail. So I am going to post a blog article there. If you follow me on LinkedIn, you'll get to know when it's posted. Yeah, so these are just some of the interesting problems that we are solving. Multimodal and multilingual are very huge for us, and content trust also is something that is very challenging given our corpus, but we're working on all these challenges right now. Cool, I think that's my time. I'm happy to take any questions. We have a few other people from Script here as well, so if you have any questions for them, please feel free to ask them.